Hello everyone and welcome back to another session in IBDP MAI course, and in this session we are going to talk about the probability and statistics topic 4.4. So in this session we are going to cover the following topics like linear regression of bivariate data. Bivariate means two variables are there, okay, and we will find how strong or weak correlation between those. With the help of this Pearson product moment correlation coefficient, we will use our calculator to find this value. Okay, I will explain each and everything in the same session with the help of GDC. Scatter diagram and how to draw the scatter diagram in GDC, how to draw the line of best fit by eye or using the technology. Then we will discuss how to find the equation of linear regression line on y on x and x on y. There is a difference between these two. Okay, and interpret the meaning of the parameters a and b in that linear regression line y equals to ax plus b. Okay, so we will discuss all these things in this session. Let's start with the uh, linear correlation of bivariate data thing. Okay, so let's consider two variables are there and how to plot the scatter diagram corresponding to those two variables. Consider the example: an alternative therapist collected data on his clients' reported level of anxiety as well as the number of trees they hugged in a course of therapy. Then we can draw the scatter diagram corresponding to that given data. First, I will discuss the theory or the concept behind it, and later we will discuss a question. So let's start with this theory, which says we have a data. Okay, let's consider that we have a data. It means we have both x values as well as y values. Okay, x is our first variable, y is dependent variable, x is independent variable. So we use independent variable values along this x direction and dependent variable values along the y is depending on x. So let's say some data points are given to us: x1 corresponding y1, x2 y2, x3 y3, and so on. So what we can do is we can plot a scatter diagram by taking the points as coordinates x1 y1, x2 y2, and plot these points on this graph. So for example, let's say we got something like this. So this is the scatter diagram corresponding to this given data. Okay, these points represents those points generated by this given data actually. Okay, now the next thing is form. We got a scatter diagram. Okay, it can be like this. Okay, there is a one more possibility. It looks like this. These are called linear forms. Why? Because if you try to join these, it's almost a straight line, right? As you can see, these are linear forms. Sometimes you may end up getting a scattered diagram which looks like this or this or this. These are non-linear form. For IBDP MAI SL course, we have only linear models, but for HL part, yes, we have other models like quadratic, logarithmic, right, and exponential, these type of. So here these are not linear, so we call these non-linear forms, and in the HL part we will discuss these in detail. So depending on the uh, scatter diagram, you can identify whether it looks like linear or not. Now let's talk about the linear. In the linear itself, let's check how we can compare the strength of those two. Okay, so you may end up getting these six different cases. Let's talk about the first one. Let's say in your data the scatter diagram looks like this. So can you draw a straight line? Yes, this time we can simply draw a straight line and data points are very close to each other. So our data is strong. There is a strong correlation this time. So we call it strong positive because the slope is positive. The gradient is positive in this case. So we call it strong positive correlation between this. So strength is strong and positive. In the second case over here, it is moderate actually, but it is positive again. Okay, it is positive as moderate. Similarly, for third one, it is very weak. Data points are not unable to form a straight line this time. So it is weak. Okay, later we will see how we can use the value of R to find the whether it is weak, strong, or moderate. Similarly, for these three, we have only negative correlation because the slope is negative going down. So opposite direction is negative. So here, for the first case, we have strong but negative correlation. In this case, we have moderate negative, and the last case, we have weak negative correlation between these. So in this way, we can define the strength if the scatter diagram is given to you then. Okay. Next. Next thing is there is an algorithm to find the estimate of the line of best fit. In the previous example, you have seen there was a straight line, right? Now, can we draw this straight line? Yes, by GDC as well as line of best fit can be drawn by I as well. So there is an algorithm to do this. If the scatter diagram is given to you, first you need to find the mean values of x as well as y. Once you get that mean point, x bar y bar, let's call that x by y bar, join, connect that point, right, draw a line passing through that point x bar y bar and try to cover same number of points above or below that line. So balancing, for example here. Okay, in this, can I draw a line? Yes. First, I need to find the x bar and y bar value. So let's say x by y bar lies over here. So we have to draw a line passing through this point and try to cover points, same number of points above or below this line. Okay, so simply you can draw a line, something like this. Just an estimation. Okay, it's not a perfect thing, but yes, by eye you can draw an estimated line. Okay, so for example here it says the following diagram shows a set of 10 data items. Scatter diagram is already given to us, right? These 10 points are representing those values. Now it says sketch a line of best fit for the following diagram. So in order to draw that line, we need a mean value also, and mean value is already given in the question. It is by x bar, this symbol. This is the mean. Okay. Now our line will pass through this, and yes, we can simply draw a line passing through this, try to covering same number of points above or below, or try to do that. Okay. So this is an approximation of the line. First part done. Now the second part, hence estimate y when x equals to 3. So from this line, you have to find that value of y where x is 3. So if you go to x equals to 3 over like here, draw a vertical line this, and corresponding y value will be the answer at this point. So what is that? It's a midway, right? 7.5. So the answer is 7.5. Y equals 7.5, okay, when x is equal to 3. So it is just an estimation. Here we are calculating the value within these points starting from this and ending up to this. But if in any question this says find the value of y when x is say 14. Okay, so if x is 14, like here, okay, so corresponding y value will be our answer, but the thing is this time it is extrapolation. Okay, we may not get a good estimation for the extrapolated value. Extrapolation, because our data set starts from x equals to 1 and ends up to this x equals to 12. So x is from 1 to 12. Finding the y for x equal to 12, 13, 13, 14 or more are extrapolated value. Or if you take a value within this range, it is called interpolation. Okay. Next question. So now we know how to draw the scatter diagram and how to draw the line of best fit. Okay. So this line of best fit is also called least square regression line for y on x. This time we are doing it for y on x because our independent variable is x, dependent variable is y. If we interchange these two, we can also find least square regression line for x on y. Okay. Now, two limitations. First, I already gave you first limitation, which is extrapolation value, right? If your data points are starting from x1 to x2 and you are finding the y value for extrapolated part, so you may not end up getting a good result. That is the first thing. And the second is if you are calculating y equals to mx plus c, okay, then you can put x to get y, but do not put y to get x, right? That's the second limitation. So if you want to find uh, x values corresponding to y values, so you need to create a new equation of linear regression. X equals, say, my1 m1y, sorry, plus c1 by changing the data points. You have to change the data point. Okay, so these are two limitations: extrapolation and depending. Next, measure of correlation. Now, how can I measure this correlation? Whether they are strong or weak or moderate? So for that, we can find the Pearson product moment correlation coefficient or Spearman rank correlation coefficient. So in this session, we will discuss this part only. By the way, method is same to calculate both of them, but here we have to arrange them on the basis of their rank. So that we will discuss in the next session. Let's talk about Pearson product moment correlation coefficient first. Okay, R value. You can simply use your GDC to calculate that. So when you use GDC, you may end up getting a value for R that always lies between -1 to +1. Remember this. R value will always lie between -1 to +1. If R is negative, then negative correlation. If R is positive, positive correlation. Okay. If R is more close to either -1, so it is strong, or it is close to +1, yes, it is strong. But depending on the sign, we can say strong positive or strong negative. If it is close to 0, very no correlation, weak correlation, you can say. In this range, it is weak. Here it is strong. In this region, you can say moderate. Okay, similarly here, weak. In between that, moderate. Okay, so you can find the measure of correlation by finding this Pearson product moment correlation coefficient using your GDC and comparing that R value in this, whether it is close to 1 or close to 0. Okay, now here's the question. With the help of this question, I will explain each and everything that we have covered so far. It says a coaching institute wants to check whether number of hours of revision are related to test score for the IB students or not. Okay, the data collected from 8 randomly selected students. So we have total n data points. Okay, n is 8. Now, in this column we have hours of revision, and in this column we have test score in percentage. Okay, now the first part says draw a plot a scatter diagram. So for that, what we need to do, if we have to do it with GDC, then I'll show you. Otherwise, if you have to plot it with hand, you can construct x-axis, y-axis, okay, and mark these points: 2 comma 58, 4 comma 63, 5 comma 67, and so on. You can mark those points, okay, like this. So whatever be the diagram you get from here will be your scatter diagram. Now I will show you with the GDC. So first go to spreadsheets, and in the first column I'm writing my x values over here, and in the second column here I will write the y values. So let's write x values and y values over here. Now give names to these. So enter x here and let's write y over here. Okay. So I will get my data like this. Now I have to draw the scatter diagram. So go to this, press Ctrl and plus page. So add a page and select add data and statistics. Automatically it will take you to a data and statistics page where your data will be shown like this. Now along the horizontal, select your independent variable. This time I am taking independent variable as hours, right? X. And along the Y, here, click here, okay, and click here and select your dependent variable. In this case, it is dependent variable, and in my case, it is Y. So I will select Y over here, okay. So once I do this, if I select Y for the vertical, yes, this is my final scatter diagram. Okay, so you can use your GDC or you can do it manually or with your hand. Now next is line of best fit. Here what you can say about the strong or weak correlation. As you can see, it is positive going up and it is strong. Yes, it is strong, right? Data points are close to the line. You can also draw the line using the GDC. For that, what you can do is go to menu, select analyze, and then go to regression and select mx plus b. It's your choice whether you select mx plus b or you select a plus bx. That's the same thing. It will not give you different answer. It's only the form mx plus b or a plus bx. Okay. So mx plus b, when you hit enter, automatically it will draw a line and gives you the equation of linear regression. So this is my equation of linear regression that we have already seen. Y equal to mx plus b, like this. Okay. So here this is slope or the gradient, or this is y-intercept. And now we know it is strong positive correlation. Okay. Now, in order to get the value of R to check whether it is strong or weak, right? What you can do is again go to your spreadsheet. Okay. You can go to your spreadsheet and go to menu, then statistics. In the statistics, select stat calculation and go to linear regression. I'm using mx plus b type. Okay. So when I hit enter and use those same for, it will ask for x values and y values. You can select x and y as your columns. Okay. So it will give you linear regression equation like this. Okay. Here you can see m, we already got this 2.75, b we already got that 52.75, and here we got r square or r. Okay, r value is this, which is 0.9949, which is very close to 1. So it is strong, right? Very strong correlation between these two is the value. Okay. Now so we got the answer for r value. Now find the equation of the linear regression. Yes, we already got that one as well. Y equals 2.75x plus 52.75 is my equation of linear regression. There is a strong correlation, yes, and yes. Does this prove that hours of revision causes high marks? In this case, okay. So now the next part. Next is, we already got answer for this. Okay, geometrical meaning of a and b. What a represents? Okay, and slope. What is the slope mean and what is intercept mean? So here in that y equal to ax plus b, a represents the slope, by the way, and y-intercept is b, and a is giving you the slope, right? Means how if I increase or decrease the 1 hour, right? How is that going to affect the test score? Okay, so you can say each extra hour of revision is associated with an average increase of that mean value 2.75. Okay, that's the geometrical interpretation. And about b, that y-intercept part, that represents if we take x equals to 0, means no study at all, what will be the percentage test score in that case? So it is 52.75 actually. Okay. Now the fifth part, it says use the regression equation to predict the score of a student who studies 6.5. So in between this, right? this one. So what we can do? We can use our equation of linear regression, that was y is equals to 2.75 x plus 52.75, and for this part I will substitute x equals to 6.5 over here. So corresponding to that, you can do it with your calculator. Okay, corresponding to that, you will end up getting this value as 70.625 something. Okay, so is it interpolation or extrapolation? Now, what can you say? Interpolation, because yes, our minimum value starts from 1 and maximum goes up to 8, and we are finding the y within this range, correct? So yes, it is interpolation. Next part. Explain why predicting x from y is not always reliable. Yes, it is not always reliable. Why? Because it's safe to take 6.5 in this case, but we cannot say ki it will work for 10 hours, 20 hours, right? That's why. So you can say this directly is not reliable to use this relation. Okay, predicting x from y is not going to be reliable, as you know, that is the limitation actually. For that, what you need to do, you need to find x value in terms of y. So my plus b. So for that, you have to interchange these two. Yes, then it will be okay to use that value. Okay, then you can enter the y value and get your x value, but do not use this same for get solving for x. Okay, so as I already explained this thing, now let's talk about the piecewise linear model, the last topic for today. Piecewise linear model. So we have already seen how to get the equation of linear regression for the given data set, but sometimes you may end up getting uh, a data which is divided into two pieces or three pieces. So what to do in those cases? Let's consider this example. A research vessel is mapping on the floor of the sea in a certain area. To do this, the boat travels directly out from the shore and measures the depth of the water continuously. So here the distance versus the depth is given to us in this table. Okay, so can we draw a scatter diagram? Yes, we can draw. So first part is explain why a piecewise linear model is appropriate. Why don't we use only linear regression? Okay, let's have a look at the scatter diagram first. So as I already gave you how to draw the method, how to draw the scatter diagram. So scatter diagram will look like this. What can you say? Is it linear? Can you say it is linear? See, it is linear from this part to this part, then again it is linear with a different slope for second. So using one line is not a good idea. Instead of using one linear regression line, we can divide it into two parts. So piecewise linear model comes into the picture. Okay, so what we will do here, as you can see, to determine if a piecewise linear model is appropriate or not, we can see two linear models here. There is a breakpoint at around this point, which is at a distance of 1 kilometer. Okay, so let's find two separate models. Okay, so first I will take those points which are 0.221, right? And then I will calculate the equation of linear regression corresponding to these. And similarly, I will take those points which are more than one, or you can include one in above or this second set. That will not make any difference. Okay, so for the first part, similarly to the previous question, just find the equation of linear regression using this data and find the equation of linear regression using this data. So let's say from here you got y equals m1x plus c1 and y equals m2x plus c2. Now combine that. Can I say y will be a piecewise function given by m1x plus c1 and m2x plus c2 corresponding to those x values. Okay, your x value in this case starts from this 0.2 and here in this case it ends at 2.0. Okay, so let's use the JDC and get this value. Okay, So for that, I'm getting something like this. Okay. So as I said, you can include one anywhere. So for the first part, I'm getting this my answer. Okay. And for the second part, I'm getting this as my answer. Okay. Now the data looks like this time. Linear line over here, first line, and there is a range on X. This one is the second one. Okay. So that was all about the piecewise linear model. Now let's use it, okay, to find the values. First part, it says interpret the gradient in your piecewise model. So we already have the equations and we know the coefficient of h will give us the slopes. So for the slope, first part slope is this, for the second part slope is 2.94. Okay. So these are the slopes, 0.4 kilometer per hour and this one. Sorry, meter per kilometer, not kilometer per hour. Okay, so 2.994 meter per kilometer. Okay, now second part says use the same model to predict the depth of 500 meters from the shore and 1.5 kilometer from the shore. So what do you have to do? You have to use these values of h to calculate the d. Okay, they are asking for finding the depth d for this as my h value first and this as my h value for the second. So if this h is 500 meter, what is that? It is 0.5. So I have to use this part to get the corresponding d value. And for 1.5 kilometer, which is more than 1, so this h value will go in this part. Okay, so my answers for these two parts will be put h as 0.5 here. So 0.0400 times 0.5 plus 1.9 is the answer for the 500 meter part. Similarly, put that second value of h in this part to get the depth. And that gives us the following answers, 2.1 and 3.66, as you can see. Okay. So that's it for this session, and I hope you got all these things. And today we have covered everything required for this correlation and regression thing. We started with calculating the correlation coefficient of bivariate data using the technology and interpret the result, including being aware that correlation does not imply causation as well. Remember this. Estimating line of best fit by eye or by using calculator. Okay, done. Then using that regression, right, to calculate the interpolation extrapolation thing. Okay. Then the meaning of those a and b, or you can say intercepts and the gradient, and constructing a piecewise linear model for the given data. Okay, so that's it for today, and this is your homework question. You can try it all by yourself. See you in the next part. Keep watching, keep learning.